hopefully this is an interesting topic, and there's a lot of interest. I'm happy to discuss over lunch as well. So I'm going to be discussing the nanoparticle emissions from non-exhaust sources. This is considering both Tyre and regular emissions. I'm going to focus on the Tyre side, and we've got some data around that, but we are going with some regular emissions as well. Just to give you some more research highlights that we've been talking with, we looked at the chemical analysis of the tires that show high concentration of specific metals. In them, so we analyzed tires on warms that have a good comparison for looking at ambient measurements of non-exhaust tires. We can then use these relative abundances for some apportionment studies, feeding them into different sorts of models and other tools that are accessible for future analysis and contribution to emissions per operate. We looked at the nanoparticle generation for Tyre emissions. They are very hard to quantify for a lot of different reasons. I'm going to get into some of them, but it's not make sense of them that I'm showing here. It's in part due to there being a variety of good research on microparticles. So we're now moving on to the nano size range, and this is becoming a bit more challenging. And so we're going to contribute to the next set of research on non-quantification for nanoparticle. We were then considering this to talk that they are allowing within our human impacts, and then being able to do all sorts of offline analysis on the direct effect of the data collection process. So we're going about our data analysis and how all of the different components are fitting together. This schematic shown on the right here is looking at where we have this image where we have combined emissions coming from a vehicle, being able to then analyze so effectively and differentiate what's coming from a vehicle compared to, say, a combustion source that is not a vehicle, being able to differentiate them accurately. As we discussed previously, having uncertainty around these measurements, of course, is quite large. And so we're trying to contribute to that as well. One way we're doing that is both generating these particles in a laboratory setting, as well as looking at unaltered samples of, say, tires and brakes, doing IPPMS on them, FPM, to try to understand the different components that are in uncovered tires to then be able to attribute them and be relevant areas. A quick understanding of the elemental analysis, which this research was published this summer out of the toxicology unit here in collaboration with them. And so we have really good analysis on about 60 light-duty vehicles, so this is both light-duty and heavy-duty vehicles, and 17 heavy-duty vehicle tires. Part of this was the collaboration with the South group, which we were very appreciative of them loaning us and sending us some negative samples that we're able to then do analysis on. And so we have not only the exact contribution with the data estimation method that was developed as part of this work, but then we can look at the relative abundances to hopefully dig out some very specific metals that are in Tyre emissions, which then can attribute in largely the model and the question. I have here all of the different metals that we looked at on the x-axis and then the relative concentration on the y-axis, the log scale. So you can see that there's quite a bit of difference between the different metal concentration. And it's comparing our data, which is in blue, versus heavy good data, which is in the brown hatch bars. And there are quite a few that actually have a significant difference between car and heavy good vehicles, meaning that there is an opportunity for being able to differentiate the non-exhaust emissions that are happening in real world environments coming from passenger vehicles versus freight vehicles. So this can contribute to tools that are then identifying the different proportions of these non-exhaust emissions, as well as able to identify how to improve them for future manufacturing of tires, as well as load going around one of the components and improve the emissions that are coming off of this non-exhaust. We've also looked at all of the metal concentration by manufacturer. This looks at all the data, not just the heavy good vehicles, but we can identify that there are specific manufacturers that will check out specific metals. This is due in part to the concentrations and the mixes that they're using for their tire manufacturing processes. And so what it is that I started identifying again, what manufacturers are contributing to different metal concentrations within different environments. This is where we really see the compositions from the manufacturer's records, so we can compare what's in the tire that were modeled by ICD versus what they're putting into the tire itself. I don't show it here, but we also looked at the difference between the tread of the tire and the wall of the tire. So we're looking at the two different components that the tire will have versus what's having the friction effect on being warm versus the structural component of the tire and how that can then affect things like leaching into waters. So that's in the next part of the research for the laboratory properties. What is important to really articulate here is that the scientific emails result we're then able to compare this to what's being collected in field data collection and help contribute to that larger analysis. We have built an in-lab integration Tyre particles. This has been an ongoing project that I'm really excited about because we can now generate Tyre particles in-house and do a lot of interesting things with it. So I have a rotating disc that will then on the bottom that goes around the circle, which we then press a fraction of a tire onto it, generate particles, which is then collected via pulsing and go into our instrumentation on the side. Right now, we have done this for PLPI measurements, so we're able to segregate these particles by size and get a number and mass associated with the emission that are coming out of this. We can also change the surface that's going to rotated. Right now, we're using sandpaper as a really high resistive material, but we can change this to a lower resistivity and be able to understand how these different materials are affecting the inside distribution of the tire emissions. A second part of this, so again, this is the LV, you can put in what's called a catalytic trigger into the chain of analysis. So we have a particle that are generated on the left hand side. They can either be sampled directly by analysis, which is shown on the right, for total particle concentration and total mass of the instrument. What we can also do is on the second line, show the total particles go to the catalytic strip, which is not always a solid component of the sample, but it evaporates and volatile and volatile component of the sample. So anything that evaporated at greater than 50 degrees will be removed from the system, and the solid component will continue on to be measured by the alpha downstream. We can then do the iterations, compare these two data sets, we compare the total particle concentration and add the semi-volatile fraction in. And when compared to solid particle concentration. So this is not only give us information to the solid particles that are coming into higher emission or greater emissions, but also on the semi-volatile fraction. So this is one ongoing work that we have both here in the UK as well as collaborators in Germany. What this data is shown for the record is a very preliminary publication mid next year, and I apologize if it's probably a bit hard to see, but what you're looking at is for A and B, you have a time series along the x-axis and concentration in number of centimeters on the y, again, Mohs scale. And what the red bar showing is an increase in temperature with the catalytic stripper. What the black graph, the line showing is the total number concentration. And what you can hopefully see here is that when the catalytic stripper is not turned on, see an increased fraction in the particle concentration and when we turn on the catalytic stripper example, that would be the decrease in particle concentration. And we can see it fluctuating throughout our symptom period as we increase the temperature of the catalytic stripper. What this can conclude is that there is a strong fraction that is semi-volatile that is being emitted from the strong emission. Quantifying this explicitly and being able to characterize this in the next challenge that we're going to be working towards in the next coming months. So now we're building the story of how we're being able to contribute not only the laboratory results of the uninformed samples, but we're able to generate some particles in the laboratory where we can then identify the components that are coming off a very isolated setting. We need now to understand how this is being emitted in a more difficult setting, so reflecting it outside and being able to compare that to what we're generating in the laboratory results. One thing that you can add would be really useful for this data is being able to know emission factors for tire emissions. This is a challenge with a community that is not yet identified, but we are able to work with and trying to have scale systems to know the exact air flow throughout that, so we can get a number per kilometer driven, including how much tonnage is being included on the risk. We can then look at the emission factors and feed it into different models that are very useful for exhaust emissions, but not yet non-exhaust emissions. This work will then also contribute to cartography studies, so we can understand the effects of nanoparticles that are being emitted from non-fossil systems. I just want to finish up with our future work that we have ongoing here, and that we're very excited about, even though this is a very special part of the work we're doing here at Cambridge, and looking at the non-exhaust emissions. We tried to collect enough mass for the chemical analysis from the Tyre group, because it's quite difficult, especially on the nano scale. Although these are the most important particles for health as society, they're the most difficult to collect for a variety of different reasons. I can go into that further. And then we also want to compare the big data to some other data that I've collected on a different study. So this is some work I've done on the journey. So we're comparing these two different collection methods. And we're also trying some work on the breakthrough data. So similar to much that up, but we want to look at the part of stack distribution as well as collecting that for toxicology study and looking at the chemical speciation for the growth emissions of that. There is a lot of work around the regular data, there's Tyre data, which is why we wanted to focus on Tyre data here. But we are excited to bring this downstream to the as well. So to show you how this looks, has been finished a couple weeks ago over in Division A, where we have this set up on the ground. This was a couple of years in the making, and so there's that get complete. So we're really excited to get a map for this program. And with that, I would like to have a few knowledge next allow me to present this data here today. That's very technology and the Department of Engineering, especially the who's the commissioner of the which is you know, looking at the work back. So thank you.
I'm so curious, what are the potential health effects before asking anyone else?
Yeah, the potential health effects, that's an interesting one because there are a lot of them. So a lot of them are looking at the inflammatory response within the lower respiratory system, and that's where these particles get down to. So they get down to the deepest part of the lung, they can then cross the blood-brain barrier and have all sorts of effects. But they extent to them and the exact effects of no, because they haven't been able to actually put these particles into stem cells where they can then monitor those effects. So it's actually quite unknown what those effects are.
But the expectations are that this is a big risk.
Exactly, yeah, the expectations are quite significant, not only for the metal side, but also the organic component that is as well.
Great, thank you. Please.
Yeah, I've gone to mine. Up until 20 minutes ago, I got the impression that most of the tyre wear pollution was actually a lot of interaction between the tyre and the road surface. So you've got kind of combined lumps being thrown out, but was a bit of tyre and a bit of road surface. Is that still right? Is that more about the big heavy stuff rather than the very fine small stuff that you're looking at, or are you missing it something?
Yeah. So the question is around how particles are being emitted and the process of which they're being emitted by, whether it's friction, whether it's heat. So the Tyre evaporate actually an evaporate, so different components evaporate. But you are right, the friction events are creating a lot of really big particles, and that's well characterized. They looked at that, it was up to 400 microns of these particles coming off as. It's this really small one that we don't understand. Is it friction? Is it is it abrasion? Is it the scrubbing of the tires, or is it actually because the tires get so hot that they're then starting to evaporate? So you get the particles nucleating that way. So you might have this very small metal nucleus, but then you have all of these semi-volatile that are condensing onto it. So the process isn't well understood yet, but that's what we're starting to see more about.
So the same issue applies to the road surface itself. You're getting these nanoparticle metals and Tyre, you get nanoparticle metals on the tarmac out of the.
Yeah, so we're trying to analyze the tarmac and the tire, as you imagine, it might be quite difficult to do that in certain areas, but there might be, certain components within the road surface itself, whether that be concrete or asphalt, or depending on that are also coming off and contributing to the non-exhaust emissions. So it's important right now to characterize them individually and then be able to bring it all together as we move into field studies. Thanks.
Right on the road first and then, yeah.
Okay, yeah, looking into the transition to electric trucks that have a different torque and a different weight on the engine to the wheels and the steer, and how this will impact and how you assess that, and if is this going to also change the approach for tire manufacturers?
Yeah, so the question is around how moving to electric vehicles is going to impact tire emissions essentially in the different ways that tires are being used for electric trucks. And I mean, the answer to that is probably yes. I haven't done a big analysis on that in and of itself. But I think if we start to then think about the load that the truck is carrying itself is becoming a bigger influence on that. Whereas, you have fuel consumption right now that's influenced by the volume and the mass that's being transported. But now you might be also contributing to your non-exhaust emissions as well. Something I haven't been able to quantify, but very interesting, where you're looking at the difference of the load versus not only the longitudinal, but the latitude and the vertical forces.
Are you getting much support or interest from the tyre manufacturers?
Yeah, the tire manufacturers are actually very interested in this. So they've commissioned a whole working group towards the tire industry project towards understanding the nanoparticle emissions. And so they want to work with researchers to understand what the emissions are and how they can then improve their processes as well as their composition of tires from the manufacturing side, because they know that this is going to be an issue, so they don't want to be caught out. They want to get ahead of the problem, and so thankfully there's some big players in that arena, and so they're definitely working with people on this. And so ourselves, KIT, which is another big group on the nanoparticle stuff, they put out some really good research lately.
The rolling resistance to the tire, obviously the big manufacturer runs a lot of them, but A rated tires, as opposed to B and C rated tires.
Yeah, the question around
Different factors there because certain so
yeah, the question around rolling resistance. We did not do that as part of our study. There is a paper that looks at rolling resistance. Off the top of my head, I can't choose by, but I know there is a paper out that looks at the difference in rolling resistance, as well as the tread thickness and how they're rated for however many miles. They're looking at that as well. I don't know.
there is a big, there will be a big reduced amount or A rated tires, so it's tire is changing. That's a big thing.
Yeah, I agree. And it's something that's also I'm interested in looking at winter tires. So in Sweden and Norway, they have an implemental stuff there. So that could be a big problem for Scandinavia. They're investigating.
What about the manifesto? Obviously, it's a very sustainable product.
Yeah, we want to try that. So we're trying to get hold of them. We haven't been able to get any samples just yet.
It's time to close the session. I want to commend the speakers for having prepared so well, for keeping to that time, and I want to thank the audience also. Nice work, Molly. Yeah. Everything.
Yeah.
Yeah.